Dear students, in this session we are going to study discriminant analysis. For this, let us first look at our data. So this is our data, which is a data from a bank which wants to give credit cards to the customers. The data already has there are 18 rows in the data. That means details of 18 customers whom they have already classified them as high risk and low risk customers. So 1 stands for low risk, 2 stands for high risk. The other details in the data are the age of the customer, the income of the customer, the monthly income of the customer, and the years of his marriage, how many years he has been married. So in actual practice there can be many more variables. So this is a data which they have given us, and we are going to perform discriminant analysis. So I will just make this data a little bit more clear by using a higher font and making it bold, so that it is clear in the video. So now we'll go for analyze. The discriminant will come under classification because we are trying to classify them in low risk and high risk, and then we go for discriminant. Of course, our risk low and high is our grouping variable. First let me just convert this variable view, and in this variable view I will clearly mention here that this is my scale, and because I want to write in my output which one is low risk, which one is high risk, so I will use data define variable properties. In that I will use this risk low high, and in this I will mention 1 stands for low risk customer, and 2 stands for high risk customer, so that in my reports it will clearly come as low risk and high risk instead of 1 and 2. Okay, so now we are ready for our analysis. So analyze, classify, discriminant. Risk low high is my grouping variable. I have to define the range. I have only 1 and 2 as the range because 1 is my low risk, so high risk, a low risk, and 2 is my high risk. Okay, and all this I am going to put them as my independents. In statistics I look for means and unstandardized coefficients, and then also I look for, in classify, summary table is what I'll go for. Okay, and then I'll go for my report. So if you see here, I have got the different tables. The important tables are this Wilks lambda table, which I have already copied. I will copy this on the Word doc. I have already done that. The second is standardized canonical discriminant function coefficients. Then we do not require structure matrix, but we require unstandardized coefficients. So this table also I will copy. Then functions at group centroid also I will require. I have already copied that. And then classification results. This also I will copy. So now I have copied all my results to a Word doc, and then let us start the analysis part. So the first is the Wilks lambda. So if you see, the Wilks lambda is 0.319, and Wilks lambda value basically can range from 0 to 1. A low value closer to 0 indicates better discriminating power of the model. Hence in this case the model is good on this parameter, right? Then In the chi-square test, if you see here, the p-value of chi-square is less than 0.05. So the variable risk low high and the result of the established model, that is the function, are not independent of each other. They depend on each other. So that also is statistically significant. So our model is a reliable significant model. Now we come to the classification results. The classification results are obtained by using the established model back on the data, right? Same data which was there, we will use the model to reclassify the original customers. And what we saw here, that in originally we had 9 low risk customers and 9 high risk customers, but this model is able to classify all low risk customers as low risk customers. But in the high risk customers, one of the customer was wrongly classified as a low risk, 8 were correctly classified as high risk. So out of 18, 17 were classified correctly, which is a strike rate of 94.4%, which is quite good strike rate. See, usually it is not possible to get always 100%, because there can be some borderline cases which can, fall on the either side. So our model has a good discrimination, power. Now we come to the standardized coefficients, and standardized coefficients from that table clearly shows that the coefficient for age is 0.924, followed by income, followed by years of marriage. So what does that show is that when we the best predictor is the age among the independent variables. Age has come out as the best predictor, which decides, which is influencing to the maximum extent whether the credit card to be given or whether the classification of the customer is to be done as a low risk or high risk. Right. Now we come to the actual model and how to classify the new credit card application into one of the two groups by building a decision rule for the and the cutoff score. So if you see this, then we are going to use unstandardized coefficient table, and here actually I have increased this. I'll just quickly show you how to increase this. So I will go to my output. When I go to my output, I see here this is showing only 3 digits, and income I want more digits because the income is high. So what I will do, I will come this and I will go for edit content, okay, in a viewer. And then once I go for edit content, I click here and then I go for cell properties and then go to format value and increase these decimals to 6 and say apply. Okay, so this is the table which I have copied, that is it shows now 0 0 0 4 times 0 and 8. So coming back to our table, so this particular unstandardized coefficients will give us the function the constant minus 10.003 plus 0.246 into age plus 0.00008 into income plus 0.085 into years of marriage, and this will give me a y value, which I have to now go to the other table, which is functions at group centroid, and you see that table shows you low risk at 1.378 plus value, high risk at minus 1.378 as the value. So if you see, and the midpoint is 0. Sometimes if the midpoint is not 0, then you need to actually find out the mean, and that is the midpoint. It is not always a 0, but in this case luckily it is 0. So my decision rule is like this: 0 to, on positive side, if the value of y is there, 1.37 is right now the mean of low risk, but whatever is positive side, I can classify them as low risk. Whatever is following on the negative side of 0, I have to classify them as a high risk customers. So this is what the rule has come, so Y value will be compared on this rule. So let us take one example. Suppose this is the a customer, a new credit card applicant has come, and these are the details. So I will use these details in this particular equation, and when I use these details in that particular equation, I got Y value as 3.112. So now based on my this decision rule, the 3.112 is far on the right side of this mean of low risk. So I clearly say that this particular customer should be given the credit card because it is getting classified as a low risk customer. So this is how we can use discriminant analysis to classify them into the respondents or the customers into two groups. So thank you very much.